Okay, let's talk about the AEPA. And AEPA stands for Arizona Educator Proficiency Assessments. And the specific AEPA exam we're going to be talking about is the middle grades mathematics. And here is the test code NES 203 exam. So if you're watching this video, I assume you are preparing for this specific AEPA exam and looking to be a middle grades teacher in the state of Arizona. So that's excellent. So what we got here in this video is a practice problem that you should be able to handle pretty well if you're fully prepared for this particular AEPA exam. Okay, so before we get to that problem, let me go ahead and introduce myself. My name is John. I'm the founder of Tablet Class Math. I'm also a middle and high school math teacher, and over the last several years, I've constructed many online math courses to actually include an AEPA middle grades mathematics NTNES 203 test prep course. So the way I do my courses, and by the way, I'm going to leave a link to that in the description of this video. But the way I do my courses is I do a lot of research on the objectives for that particular certification exam, and then I try to come up with a custom math curriculum that can, basically get you as ready as possible for this particular exam. But for the AEPA middle grades math, if you haven't seen the kind of math that's on here, you're going to need to know more than just middle grade math. Okay, you're going to need to know, I think I would classify it as advanced high school level mathematics. So more than just say basic algebra and trigonometry. You're going to have, or basic algebra and geometry. You're going to have to know, trigonometry. They're advanced, mathematics topics that are taught in high school. So with that being said, let's go ahead and get to this problem here. Okay, so first of all, let me just tell you what the problem is, and then in a second, I'm going to give a bit of a hint, and then I'm actually going to solve the problem. All right, so what is it? Well, we got some trigonometric stuff going on here. What I'd like you to do is to use your knowledge of trigonometric identities to simplify this expression, okay? So the thing about this is, and I'm not going to give you the hint just yet, but the thing about this, when you're working with identities or in trigonometry or just in mathematics in general, there is a lot of stuff that you kind of have to kind of remember. So it is what it is in terms of, how much of this stuff is going to be given to you in terms of like a formula sheet on the exam. You just don't know. But the problem, this particular problem, you should be able to handle hopefully just by memory, okay? Because there's some of these things that we're going to be talking about. Again, it's a lot of math, but a lot of this stuff you kind of have to try to commit to your long-term memory. Okay, so with that being said, if you think you know how to do the problem, go ahead and pause the video and do so. And here comes the hint. So if you don't want to hear the hint, go ahead and pause the video. All right, so we want to simplify this trigonometric expression. We're going to use trigonometric identities. Now, when you're studying trig identities, there are a whole bunch of identities. And this is kind of like a rite of passage when you study trigonometry. You get to this point, at least for, teaching it, you get to the point of teaching trigonometric identities and doing all kinds of things with them. They're extremely important in trigonometry. These identities really help us a lot because they're equivalencies, okay? So you can have one big expression equaling to another expression, so it makes our life a lot easier. So it's not just one of these topics that, it's like busy work, if you will. There really are, fundamental to the study of trigonometry. So there are a whole bunch of identities that you need to know. For the ones that we need to know for this particular problem, I'm going to go ahead and give them to you now, would be sine squared of an angle, let's call it x, plus cosine squared x is equal to 1. And then we got to know that tangent of an angle x is equal to sine x over cosine x. Okay, so those are your two big hints, and hopefully, even if you're not quite sure what what to do, you can just use your knowledge of algebra and substitution to simplify this problem. Okay, so let's go ahead and knock this out now. This is again I would classify this as a basic level, yeah, a medium, definitely not what I would say a more advanced level trigonometric identity problem. Okay, this is something you should be able to handle pretty well. Again, um, in order to do this problem, you're going to have to know identities, right? And these are just real kind of basic identities. There's a lot of other ones, double angle, half angle, and some of those right there, if you don't remember those exactly, that's okay. But things like this, sine squared x plus cosine squared x, and x represents an angle equals 1, or the tangent is the same thing as sine over cosine. These are fundamental trigonometric identities, and I would encourage you to, yes, commit these to memory. All right, and there's other ones that are important as well. All right, so here we have 1 minus cosine squared x, and then we have tangent x here. Well, we can't really do anything in terms of simplification until we get the same trigonometric function, both in the numerator and denominator. So we have to look and see, okay, 1 minus cosine squared x, what can I do here? Well, if you are nimble with your algebraic skills, we can rewrite this 1 minus cosine squared x as sine squared x. I'll show you that in a second. And then tangent x, I can rewrite that in terms of sine x over cosine x. So I'm going to try to get it as much of this written in one trigonometric function. So it looks like we can use sine to help us out. So let's go ahead and do that now. So 1 minus cosine squared x. So we know that sine squared plus cosine squared is equal to 1. Now, of course, I'm not writing the whole thing out here, but if I move the cosine squared to the other side, I have sine squared is equal to 1 minus cosine squared. So here I have 1 minus cosine squared x. So that's the same thing as sine squared x over, now I have tangent x, but I know tangent is the same thing as sine x over cosine x. Let's go and write that there. Sine x over cosine x. Now, at this point, hopefully you can see, okay, we have what we call a complex fraction. And, maybe you didn't even know the term, but you should know the term of that. You're going to be a math teacher. A complex fraction is a fraction within a fraction, like we have 1/2 divided by 2/3. So what do we do here, right? So this is a division operator, so I can just think of this as sine squared x divided by, let me give myself some room here, divided by sine x over cosine x, okay? Now at this point, knowing your stuff, we're going to go ahead and flip this over and turn this into multiplication. So now we have sine squared x times cosine x over sine x, okay? And this will be over 1. And now we can just go ahead and write this way. Sine squared x times cosine x over sine x, okay? Now here, this notation, don't let it confuse you. Sine squared x is the same thing as sine x times sine x. So I can cross cancel one of these sine this sine squared x. I can cross cancel a sine, and that leaves me with sine x times cosine x. And that is what this simplifies to. Okay, so instead of working with this, okay, we can work with this, right? And if you're calculating angles, let's say the good old days before calculators, okay? Maybe you were taking trigonometry in 1930 or something like that, right? Of course, trigonometry has been around for a long, long time, but when you had sine, cosine, tangent, all these, angles, you would have to reference in the back of a textbook. Here, let me just draw a little book. So you have a book right here, and it's trigonometry, and let's say the year is 1930, okay? No calculators. So if you needed to look up the sine of an angle or the cosine of an angle, you'd have to go to the back of the book, and quite honestly, these tables are still they're still in textbooks today. At least they should be. It all depends on what the textbook is, but oftentimes you'll see those tables back there, but they're completely ignored. They're like, nobody really looks at them because they're like, hey, what's this? Because you just go into your calculator, all right, and do that. But anyways, the point is this: you would have to go, find out all this information, plug it in, get the tangent, get the cosine squared, do all this arithmetic. Um, and the whole idea behind trigonometric identities is instead of doing something like this, maybe we can just do an equivalent problem and get it down to like this, okay, which would be easier to handle. Okay, in other words, less arithmetic, but equivalent to that expression. So, again, this is why you need to be able to work with trigonometric identities. Now, again, well, not to be redundant, you're at the middle grades level math, but you're preparing your students. You'll probably be teaching algebra for sure, and maybe even geometry, but you're preparing your students for, high school level math, many of which are going to go all the way on up to probably maybe calculus. You just, don't know. But again, you at the middle grades level, are going to need to know a lot more math than just, algebra, basic algebra, middle grade math. You're going to need to know all that stuff, fractions, decimals, because that's probably the main focus of what you're going to be teaching, of course, because I've taught all of these grades. But again, for this certification exam, you're going to need to know a lot more than that. And that's a good thing too, because, you might decide that, what, I want to teach high school math. And, you can make that move and teach this stuff. I just enjoy teaching math. I taught both high school and middle school, and they are different, but they're both very cool levels to teach. Okay, so let's go and wrap up this video. Again, I'm going to leave a link in the description of this video for this particular AEPA exam, my math test prep course for this. So if you want to check that out, all my courses have taken me literally years to build, so they're really high quality. And if you're not sure, how to study for this, a course like mine can definitely help you out. If you're new to my YouTube channel, I've been on YouTube for several years and I already have hundreds of videos on my channel that can help you out. So if you like my teaching style, you can check those videos out. And I'm posting new stuff all the time, so hopefully you consider becoming a subscriber. And if you enjoyed the video, definitely appreciate a thumbs up. And leave me some feedback. What's your kind of history coming into taking this exam? Are you coming from high school to college to teaching, or maybe you're making a career switch? Maybe you're coming from the elementary level or from a different subject, okay? Any feedback is good feedback, but I do a lot of videos on teacher certification exams throughout the country. It's kind of a big part of my passion is to help fellow teachers prepare, for whatever they're going to be doing in the classroom. But I will say this much. Teaching is half your professional knowledge, your professional certification, going to school, getting through these exams, getting your certifications, etc. That's half of being a teacher. The other half is really just learning the job, things that you learn a little bit about in a book or in a classroom, but you're not truly going to master until you actually, have a classroom with kids, etc. So when you're thinking about math, yeah, you got to know your subject, but then you got to know the other stuff about teaching. That's more like an art form, handling parents, handling kids, handling, differentiation of instruction, working with the administration, fire drills, everything, right? So give yourself time to develop into an experienced teacher. I would latch on to those veteran teachers that really know their stuff, okay, and learn from them until you find your own way. And that's the way it should be. You don't have to copy someone, a particular teacher and be like, oh, I have to be exactly like them. You could be successful in your own way. There's all different types of teachers that come at teach in all different types of styles that are highly effective. So you have to find what works for you. But until you've developed the experience, learn from others and give yourself time to gain that experience. All right. So with that being said, I definitely wish you all the best on this AEPA exam. You could definitely do well on it, but you're going to, have to commit to learning a lot of math. Um, Again, don't underestimate this exam. People do fail these exams. Matter of fact, a lot of people do, and they have to come back a second or third time until they actually pass. But definitely wish you all the best. Thank you for your time, and have a great day.